Good morning. Now start second unit, unit 2, hydrothermal scheduling. The first unit, economic load dispatch. In the previous unit, we have dealt with the problem of optimal scheduling of a power system with thermal plants only. In the previous units, we have deal with the problem of optimal scheduling of the power system with thermal plants only. In this unit, the operation of system having two plants. There are hydro and thermal power plants, and both are involved. Once both thermal and hydro plant are interconnected, total operating cost of the power generation is to minimize. Because of both plants are interconnected, the hydro power plant is the power generations by using the fuel of water. In thermal power plant, the fuel is coal. The comparison of hydro power plant, the operating cost is less and thermal power operating cost is high. So both are interconnected is nothing but a hydrothermal. To minimize our aim to minimize the cost of power generation. So this is the hydrothermal scheduling. Now start for introduction. So here the what is meant by hydrothermal system. So when one hydro plant and one thermal plant together supply is power to be centralized load, the system, then such a system is called hydrothermal system. So here in this figure, this is the thermal power plant, this is the hydro power plant are connected to supply together supply to power centralized load. Then the system is called hydrothermal system. So one hydro plant and one thermal plant together supply a power a centralized load. Then the system then such a system is called as hydrothermal system. Here in this figure, this is the thermal power plant, this is the hydro power plant are interconnected to centralize to supply the load. So here in this diagram, this is the hydropower plant, water inflow, this is the reservoir and water discharge. So the operation of the system becomes a more complex because of when two different generating stations to supply power is centralized. So one thermal power plant, the operation is individual thermal power plant, the operation is easy, but here the two thermal power plants are interconnected. So operation of the system become a complex when two different generating stations supply power to the centralized load. Next, hydro plant, we know that the hydro plant having the low operating cost and high capital cost. So the establish of hydro power plant, it is initial investment is very high and the operating cost is less because of the fuel is by using the water. So the constructing of dam and reservoir and everyone the establish of the and all established to the hydro power plant is a cost is very high compared to thermal power plant, and operating cost low operating cost of the hydro plant is a low. Operating cost is low. This is the operating costing become a complex. Operation of system become a complex when two different stations supplying a power to centralized. So hydro plants having the low operating cost and high capital cost. where thermal power plant is having the have high operating cost and low capital cost. In thermal power plant, the operating cost is very because of the fuel is a coal. The coal is very cost, very high cost, and the low cost. In a interconnected system where centralized load during Karu, thermal plant are used in base load plant, where in hydropower plant are used in a peak load plant. Because of hydro plants can be brought to bus bar very fast in few minutes, they have high reliability. So then power generation in hydropower plant is very start for the few minutes. To power generation is a few minutes. In the they have a high reliability. They have a high reliability. Or interconnect system, certain load duration curve, thermal plant used as base load plant, whereas hydro plant is used for the to meet a peak portion of the curve. Based on the demands, the load power system, based on the demands, the loads on the power system are fluctuating from time to time. So loads are classified into base load stations and peak load stations. So the operating cost of thermal power plant can be minimized by the generating power through hydro plant for a given period of time when the water is available. The system is called fundamental system. So our main aim to reduce the operating cost of thermal power plant can be minimized by through the hydropower plant. When the water is available, then the system is called as fundamental system. Based on the demand, the load power fact system are fluctuating from time to time. So the loads are classified as the base load stations and peak load stations. What is meant by base load plant or base load? The load on the power system which does not vary the whole day is called base load. Today, one day the complete the load on the power system does not vary. The demand is does not vary. Demand does not vary the load the whole day is called as base load plant. Peak load means the so here the base load, the output power of thermal and nuclear station is maintained a constant to keep the station is in a thermal equilibrium. So in the base load plant, so thermal power plant and base load plant, base load plant are examples for nuclear power plant and thermal power plant. So the output power of the thermal and nuclear power stations is maintained to constant to keep the stations in a equilibrium. Thermal equilibrium is called. The example for base load plant is a thermal power base load plant, thermal power plant, and nuclear power plant. So some of hydropower plant also come under this category of base load plant because of they have hug water storage capacity. Generally, head of the water in the reservoir will be high during the rainy season. So some of times the hydropower plant is also treated as a base load plant because of the hug use water. The use water available had high, very high use water in available in the reservoir. That time is only hydropower plant can be treated as a base load plant. The next one is the peak load plant. Peak load plant, the maximum load demand on the power system which is above the base load is known as peak load. The peak load means peak means maximum. So the maximum load demand on the power system which is are above the base load are known as peak load is called as base load plant. The example for the base load plant, gas, diesel and pumped storage plants are used in the peak load plants. Peak load plants. What are the advantages of hydrothermal scheduling? The first, low initial investment and maintenance cost. So the combining for both hydro power plant and thermal power plant. So our aim to reduce the operating cost of the thermal power plant. Both our plants are interconnected by using the fuel and generate the fuel of water, generate the power. So it is the advantages of one of the advantages, low initial investment and maintenance cost, and increased reliability of power supply. In case of increased reliability is quality and quality is the improved. So increased reliability of power supply means It is one of the coal is not available by using the hydropower plant, by using water is available by using to generate the hydropower plant, and what in the dry seasons the water is not available by using the coal thermal power plant. So totally the combined of hydro and thermal plant, so increasing the reliability of power supply and reduce the spinning reservoir requirements. Reducing the spinning reduced the spinning reserve requirements in the another discussion. This point is a discussion later. And cost per unit of generation is decreases. Cost per generation of decreases. So the cost per unit of generation, our main aim is the cost of generation is reduced. So the total power generating, the total combined for the thermal and power, thermal and hydro plants are interconnected, the cost per unit of generation also decreases. So those are the advantages of hydrothermal scheduling. Next, in this advantage, one of the point is there. So reduce spinning reserve requirements. What is meant by spinning reserve requirement? It is defined as the total amount of power. It is defined as the total amount of power generation available from all the units are synchronized. That grid system minus load demand and losses being supplied is called as spinning reserve. What is meant by spinning reserve? It is defined as the total amount of generation available from all the units are synchronized to the grid system minus load demand and the losses being supplied is called as spinning reserve. So if a spinning reserve is available, loss of the one-off unit can be taken care by remaining units in the systems. Spinning reserve is available, losses of spinning reserve is available, losses of one unit can be taken care by remaining units in the system. Spinning reserve is essential in interconnected system. A loss of large unit in the system may result under frequency problems. So one of the unit large unit system may result in under frequency. However, if sufficient spinning reserve is available, the losses of one of the unit can be taken care by remaining unit of the system. So it is called as is called as spinning reserve. So reduce spinning reserve requirements in advantage of hydrothermal scheduling problems. So what is the spinning reserve? It defined as the total amount of power generation available from all the units synchronized to the grid system minus load demand and the losses being supplied. So in spinning reserve is a very essential and interconnected system as the losses as the losses of large unit in the system may be result under frequency problem. If the spinning reserve is available, loss of one units can be taken remaining of the units in the system. So this requirement reduced in spinning reserve requirements is reduced in the case of hydrothermal. Both are interconnected systems is reduced. So thank you.